आदरणीय अध्यक्ष महोदय, सदस्य सचिव महोदय और श्री डॉक्टर आनंद शंकर जी, my colleagues from State Pollution Control Board and participants who have joined us online. आज के इस लेक्चर सीरीज में आप सभी का हार्दिक अभिनंदन और स्वागत है। जैसा कि आप जानते हैं, परिषद के द्वारा प्रत्येक माह एक स्पेशल लेक्चर आयोजित किया जाता है और आज का ये इसी कड़ी में आज ये 29th लेक्चर है, that is on analysis of PM 2.5 variations and prediction using meteorological and air quality data, a case study of पटना। और इस पे चर्चा करने के लिए हमारे साथ आज मौजूद हैं डॉक्टर आनंद शंकर। He is a learned scientist from Indian Meteorological Department, Regional Office, Patna. तो कार्यक्रम में आगे बढ़ते हुए मैं अनुरोध करना चाहूंगा सदस्य सचिव महोदय से, सर वो वेलकम एड्रेस देना चाहेंगे सर, प्लीज।
It's a matter of great pleasure and privilege to welcome Dr. Anand Shankar, scientist from Indian Meteorological Department, Regional Office, Patna, on a very important and in today's day-to-day discussion topic of the analysis of PM 2.5 variations and its predictions using meteorological data of the AQIs. Friends, we all have now proceeded in the winter season where AQI index is challenging every year. So in the mean high time, the relevance is most important now. And therefore, I request and welcome Dr. Anand Shankar to please address us and put his long experience, insight into the topic to enlighten us on this matter. I seek the approval of Honorable Chairman, sir, to further start the proceeding of the meeting. Thank you.
Thank you, sir. और I have been asked to discuss the significance of today's topic. और सर ने कहा ही है और आप सभी देख रहे हैं कि इसके बाद इसकी सिग्निफिकेंस को बताने की आवश्यकता नहीं है मेरे हिसाब से शायद, क्योंकि पूरे भारतवर्ष में स्पेशली इन नॉर्थ इंडिया वी ऑल आर फेसिंग एयर पोल्यूशन these days in winter season as every year. तो निश्चित रूप और खास करके in our area the air pollution is mainly due to the particulates and of course PM 2.5, the presence of PM 2.5 in higher concentration is a matter of concern. तो निश्चित रूप से ये टॉपिक बहुत ही रेलिवेंट है, सिग्निफिकेंट है और बहुत ही अच्छा मौका है। Yes, I do share the sentiments of our member secretary sir that we feel privileged to have with us Dr. Anand Shankar ji, a good friend of all of us. We know each other since long, or it is we all are excited to hear him on this very topic, which is very much relevant and significant for all of us. It concerns our health as well as the health of the environment. To share the details about Shri Anand Sankarji, I would like to invite our colleague Shri Arunji to say a few words to introduce the speaker to, for the benefits of our all the participants. Shri Arunji, please.
Uh, Thank you, Naveen ji. First of all, welcome to Dr. Anand Sankarji, scientist working as the scientist Indian Meteorological Department, Regional Office, Patna. आज हम लोग के बीच में ये आए हैं और इनका काफी कार्य जो है पर्यावरण के क्षेत्र में और फोरकास्ट के क्षेत्र में रहा है। मेट्रोलॉजिकल डिपार्टमेंट में भी जो है आपका जो फोरकास्ट हो रहा है पहले के फोरकास्ट से काफी डिफरेंट है और सटीक भी आ रहा है। तो संभवतः ये इनके कार्य के बदौलत ऐसा संभव है हुआ है और साथ ही अब बोर्ड ने इंडियन मेट्रोलॉजिकल डिपार्टमेंट के साथ हैंड होल्डिंग किया है सो दैट कि पोल्यूशन का भी इफेक्ट जो है हम लोग फोरकास्ट कर सकें। तो इनके बारे में एक छोटा सा परिचय देना चाहूंगा। तो ही इज a scientist at the meteorological department, Ministry of Earth Science, Government of India, where he plays a key role in advancing meteorological researches and forecasting. With a strong academic background, including BTech, Master of Science, and ongoing PhD researches in the electronics and communication engineering, his work focused on leveraging cutting-edge technology like artificial intelligence and mechanical learning to improve weather prediction system. His doctoral thesis specifically addressed the use of AI for visibility prediction in the aviation, highlighting the intersection of meteorology and technology in enhancing the aviation safety. He is in his professional journey, he has received comprehensive training in weather forecasting, climate monitoring, and hydrology from renowned national and international institutions. This includes a specialized course in atmospheric phenomena, short-term climate monitoring, and the application of remote sensing and GIS technologies. His expertise span is broad spectrum of meteorological field, including climatology, agrometeorology, aviation meteorology, and flood forecasting, with a particular focus on the integration of artificial intelligence and mechanical learning to automated and enhanced forecasting models. He has worked extensively with meteorological instruments, including Doppler weather radar, to monitor and analyze weather patterns such as heavy rainfall, thunderstorm, and lightning. His contributions to impact-based forecasting are significant, with a focus on providing accurate, timely weather warning for public safety and disaster mitigation. His AI-driven researches aims to improve forecast accuracy and prediction lead time, crucial for sectors like aviation, agriculture, and disaster management. His work has led to development of models that use AI to predict and estimate weather phenomena more reliably, with a particularly valuable for operational decision making in industries affected by weather. In addition to his hand-on work with meteorological technology, he has published extensively with 19 peer-reviewed research papers, numerous conference proceedings, and several book chapters. His publication focus on key areas such as artificial intelligence application in weather forecasting, climate variability, and the integration of mechanical learning techniques into weather prediction system. His research has generated recognition in both national and international scientific communities, and his work continues to have a lasting impact on the development of modern meteorological practices. His decision to advancing meteorological science and technology has positioned him as a leading figure in the field, with particular emphasis on improving public safety through more accurate and timely weather forecasts. तो अभी आपने देखा कि इनके द्वारा जो है फोरकास्ट के सिस्टम के लिए काफी कुछ किया जा रहा है और इनके द्वारा जो है अच्छा कंट्रीब्यूशन दिया गया है इन्हीं शब्दों के साथ।
हाँ, हाँ।
आज के इस कार्यक्रम में जो प्रतिभागी गण हैं, जैसा कि सदस्य सचिव महोदय द्वारा कहा गया था कि माननीय मंत्री द्वारा निर्देश दिया गया था कि जब भी कोई शिक्षा का प्रसार या कोई कुछ काम करते हैं इसमें, तो ऐसे समझ में औद्योगिक इकाइयों को भी इसमें सम्मिलित कर लीजिए। उसी के अनुपालन में आज जो कार्यक्रम है मंथली लेक्चर सीरीज है, मैंने ऑलरेडी थर्मल पावर प्लांट जो है सर बिहार के जितने सभी को शेयर कर दिया गया है। आई होप दिस फाइट की सब है ज्वाइन कर लिए हैं थर्मल पावर प्लांट, तो वो लोग भी अवेयर हो जाएंगे सिस्टम से, ताकि हमारा एक अनुपालन भी होगा और उसके हिसाब से अवगत भी होकर के इस कार्यक्रम में आगे होगा। मैंने इनको शेयर कर दिया।
एक चीज बता दें, he has cleared the UT sequence. Very
Thank you. Thank you, Arun ji, and of course, Jaspal ji, for updating us. Or I propose a big hand for Dr. Anand Shankar ji, and take the privilege to invite him for his lecture.
सर यहाँ से बोले क्या वहाँ खड़े होकर बोले
नहीं, यही सब बोलेंगे, क्या दिक्कत है?
तो नोट कर दीजिए।
थोड़ा सा आगे
I think it is audible now.
Yes.
Thank you very much for your warm welcome. Now I start my lecture. First of all, I am very thankful to the Adhyaksh Mahoday, member सचिव, जिन्होंने मेरे को अपॉर्चुनिटी दिया कि एटलीस्ट जो वर्क है वो आप लोग पास रखें और इस पे जो भी इनपुट है, फीडबैक है, डिस्कशन है, वो हम आप लोगों से चाहते हैं। और मोस्ट इम्पॉर्टेंट, बहुत सारे जो ऑनलाइन जुड़े हुए लोग हैं उनसे भी आग्रह है कि वो आप कुछ भी अपनी कोई भी क्वेरी हो वो आप आस्क कर सकते हैं। इसके अलावा whatever if you're in mind you can discuss with me. So now I start my presentation. Today for my topic for presentation is analysis of PM 2.5, variations and predictions using meteorological and air quality data, a case study of Patna, Bihar. We already know that the pollutions and weather are interrelated. Even all those NWP models that is used for the predictions of weather, that is after some changing, they are also used for the predictions of PM 2.5, PM10, SO2, ozone, and you can say the AQI. So weather and pollutions are interrelated. Only the chemical transport model used in. I am also going to discuss about the whatever the services of the air quality for the IMD is available, that I will also discuss. My outline of the presentation, we can show you all those methodology and everything, data sets and results, and we'll discuss in the details. And one picture I show you in which the geographical location of the Bihar is showing, where you can see it's a topographical map of Bihar, where the altitude of the Bihar is only varies from 41 meter to 141 meter. Around only 100 meter is the altitude difference, even the lowest point of the state to the highest point of the state. So this may also one of the reasons for the very high PM 2.5 concentration in the state of Bihar. That I will discuss in the detail. Next, please. So next comes to the introduction. So we already know that a lot of things that PM 2.5 or particulate matter or suspended particulate matter is one of the leading cause of the short lifespan and mainly in the developing countries. And 9 in 10 air pollution related deaths occur in low to middle income group of countries. So this is one of the major concerns of air pollution for the low to middle income group countries, as well as even the vulnerable population, the poor population are more vulnerable to the air pollution, and significant reduction in life expectancy due to long-term exposure. These 2 or 3 are very concerning points that I want to show you. All are thing is the general points only. Next, please. So come to the state of Bihar. State of Bihar, what we found, it's Bihar particularly Patna faces poor air quality with significant seasonal variation. It's what I try to understand from the trend. I try to bifurcate the seasonal and trend part. Then what we got, seasonal is one of the significant variation in capital city of Patna. And what we found in our study that maybe the industrial emissions and traffic, these all are the major causes of the pollution in the state of Bihar, as well as the PM10 is the one of the concerning point for the state for the high AQI level. So PM 2.5 is also concerned, but PM10 is more concerned for our state. What we got from our study also. So, and in the winter season, particularly in the November month, where the weather activity is very low, even the inversion layer is very low, planetary boundary layer is low, then what we got, that the pollution level is very high, usually in the month of November, and then we got into the December when we got the first rainfall, then it got reduced. In the picture, you see the one of the animation in which the PM 2.5 level analysis as well as the forecast that is done through the one of the SILA model, one of the state of the art NWT models of the IMD that we got. That what we found that the PM 2.5 is driving from the western part of the India, and it is entering across the state of Bihar and just exiting from the small part of the northeast Bihar. You can see the animation, it's like a river flowing through the, and this is one of the major concern in the high PM 2.5 concentration in the North Bihar districts as well as the adjoining Patna and area. There is also local factors also. Next, please. So objective of the study, I show you that what we provide this analysis variations in PM 2.5 concentration in Patna using air quality as well as the meteorological data. That what I show you that those are very interrelated, and identify the primary influencing factors for PM 2.5. This is what one work I try to do, that which meteorological factors is more influencing the PM 2.5 in the state or the representative station of the Patna. Next, please. And in the picture, I show you one picture of ventilation index that is just a model product. And for this analysis, particularly for the analysis of PM 2.5 over the Patna, that the data source I took from the 2016 to 2023, and that data of all those meteorological data has recorded every half an hour at the airport. That data I have used, as well as the meteorological data I have taken from the 2016 to 2020 from the planetarium site of the Bihar State Pollution Control Board. After that, later I took from 2020 onwards the data of the nearby the eco park data that I took for the analysis, and I analyzed this data of the hourly basis. Then what we got, and I show you the calibration standard that what we follow for the meteorological parameters. It's very accurate because the airport required accurate meteorological observation. So we used to we have a defined parameter. So even the temperature accuracy, we are keeping at plus minus 0.1 degrees centigrade only. For wind speed, we are not tolerating beyond plus minus 0.25 meter per second. And for the for the pollution parameter data, we have taken from the state pollution control board that follow the NAVL standards and all. Next, please. So you can see these are the air quality data that I have taken for our analysis, PM 2.5, NO2, CO, SO2, and ozone. And meteorological factors that I have taken that from dry bulb temperature, dew point temperature, relative humidity of every hour, wind speed of every hour, as well as the weather, like present weather that we are reporting in the aviation service that the weather at the time of observation, that is called present weather, as well as the past weather, that is the previous hours. What was the weather? Weather may be fog, weather may be thunderstorm, weather may be the rainfall, like that, as well as the station level pressure. That data I have took for the analysis. And you can see the range also. What we got, even PM 2.5, the lowest, what I was found for the study period, it was 3.5 microgram per meter cube to 1049 was the highest. So these are the parameters that I took for the analysis, and I took this data after all those feature selection. There is a feature selection is a word that means best correlation that we got from this data. Thank you. Next, please. So these are the I explain you this what is the present weather and past weather. Maybe it's maybe it's new for the other person who are not working in the meteorological department or related weather field. Where present weather, we are 100 types of weather defined by the WMO. We are using that codes only. Even the airport, we have a thunderstorm for there is a specific code. Fog, there is a specific code. Thunderstorm with rain is a specific code. Thunderstorm with lightning is a specific code. These are all those weather codes we are using, as well as the past weather. Only 10 types of weather codes are using. These are also used for our analysis. Next, please. So you can see the methodology in the meteorological data from where I have took from, and as well as time stamping. That I show you, the seasonal variation is one of the important parameters in Patna and even the Bihar. So I took the time is also one of the parameters for the predictive model. That what we used for the predictions of the PM 2.5. So all those parameters, as well as I tried to use the correlation coefficient, SH SAP value, that which are the influencing parameters for the PM 2.5 is the responsible, as well as the what is the trend during our study. These all are calculated that in through one block diagram. I show you all the parameters in which I did the analysis part as well as the predictions part. For the predictions, I used a simple machine learning model, that is a random forest, and I try to check that model. It's working well in the data means weather data as well as the air quality data of the Patna, and I will show you how it works and how accurate that is. Next, please. So these are the methodology as well as the random forest. I took the random forest model. I took the random forest model because it's working on the several learning techniques, and in the end we are just ensemble all those methods. So its accuracy may be the better during the even the simple weather. Maybe in the extreme cases it may not work better, but it will be almost totally following the trends of the even the extreme time also. So that's why it's working on the ensemble learning technique. So I took the random forest model, and it's a bagging technique that is working on the variance, that improve the variance as well as improve the bias of the model. So these are the following advantages I written, that it's a robust against overfitting. But if we practically maybe the deep learning model that we know about the AI model, that may be more important. Next, please. So these are the steps of the flowchart that random forest I used. And I try to make it the model robust. We are taking the several training data in the different parts of the data sets, and for the K cross validation that I used, so that model will be robust. In the weather, what we found, even all those NWP models that we are using for the weather forecasting, that is hardly 60 to 70% correct. And how to improve that model? That for AI model technique that I used several things like grid searching, k-fold cross check, as well as the hyperparameter tuning for the best results. Next, please. So, explaining learning with the SAP value that I show you, the SAP technique I used, that which are the influencing parameters for the PM 2.5 that I finding through this module, and these all are implemented through the Python module only. Next, please. So now comes to the results and discussion part. And you can see that I try to make it the diagonal variations of all those 12 months, how it varies from the morning to evening, all the time I took from in the UTC timing, in the GMT timing. And what we found that even in the winter season, the usually two peaks are coming on. You can see that in the morning hours it's coming on. Early morning is one of the peak, as well as the in the office hour time, 11 UTC time, or 6 UTC times. That what we got, there is one of the peaks, and that may be due to the vehicular emission, because it's a traffic increases in the around 10 to 11 UTC time, 10 to 11 IST time, and 6 UTC time it gets increased. So, this day peak is coming at that time, and the night peak in the early morning hours. And what we got in the, even you can see the in the winter there is usually all those works are little bit late, half an hour late. So you can check all those months. Even I try to make it color coded in the different season also. Even season also we have means June, July month in the yellow color, yellow June, July, August, September, October in the green color, and all those symbols, and that depict that how many peaks are coming on and how it varied diagonally, as well as you can see the even the month of Jan, November, December, it's a very high AQI concentration, but other month in the month of you can see the monsoon month where the lot of rainfall is happening, it's a very reduced PM 2.5 concentration in capital city of Patna. And one of the important things that how derive this diurnal variation, that is the planetary boundary layer, that we can say the inversion layer also. It's you can see the mixing height where the air is mixing, that also varies diurnally. That defined the even the that is one of the driving factors of the diurnal variations of the PM 2.5 also. Next, please. So you can see the means monthly variation also I plotted. It's a very complex picture, you can see it, but I try to make it simple. This is only the finding is that even in the month of monsoon, if there is some rainfall is less, then the air quality is very high. Agriculture activity during the monsoon is also one of the responsible factors for the PM 2.5. And if the rain is not happening, like you can see in the month of August in 2021, 2022, there is a very less rainfall. Then the AQI is also get rising. And in the state of Bihar, even the Patna surrounding area, the agriculture activity as well as the lot of industry, you can see the brick factory is also responsible for the poor PM 2.5 concentration. So some monthly variation is also one of the major cause. It's mainly dependent on, I think, the agriculture related activity as well as the industry. And in the daytime, the traffic congestion is also one of the issue for the high PM 2.5. Next, please. So in the annual concentration, what we found that 2000, this data has taken from the 2016 to 2023. So 2017 and 2020, what we found highest median PM 2.5 levels, and 2020, what we found increase in moderate pollution days, decline in extremes. So from the analysis, what we found for the next 6 to 7 years, what we found 2022 onwards, the extreme of the PM 2.5 was reduced, but the moderate pollution days are increased. You can see the value in the one of the chart in the 2020, the moderate pollution values are also increased. This may be because of the even the state pollution control board, even all those authorities taken proper action so that even the moderate pollution even reduced, but still the medium pollution level is still persisting. Even it increased in the 2022 and 2023 also. So these are for the 3-4 years. This may be the action taken by the state pollution control board, maybe causes for that. So now come to as well as the public awareness may also work. Next, please. Or even if see the for the standard, still we have a even daily and number of pollution days still more than 250 in the state of Bihar. So even whole of the year, you can see the stand we are below standard and we have poor air quality also. Now comes to the predictive model that I used and that I saw in the random forest model. And it's one of the plot I show you how it works in that one. And what we found, it's the R square error. R square error presents that for the unknown data sets, how accurately it predict on unknown data sets. That is represent the R square value, and it's a 0.80. It means for the around 80% of cases, it's maybe work better in the prediction model. This is for hourly predictions as well as for the percentage MAP I checked. It's only the mean percentage error is 75% and more. So the prediction accuracy of this model is, you can see in the layman language, it's 75 to 80%. It's maybe accurate up to the more than 24 hours lead time. So these are the model predictive capability that I show you, that I try to make it, you can see even I make other models for the weather prediction that I try to put in this one, and I try to tune in this one for the various things. So it's one of the state of the art. Even the Chinese used to even after all those works on the real time data, and even the Chinese model are also equivalent on that one. And other countries' model I also compared for this one. Next, please. So now comes to the influential factors that I show you for the PM 2.5 concentration in the state of Bihar. You can see the representative station is the Patna. And what we got, the percent weather conditions. The weather conditions is the most influential factor. And from this SAP analysis, we got the very 100, I think the more than 400 value is there. After that, the station level pressure. Pressure is the other major factor that influence the PM 2.5. After that, relative humidity. Usually, the relative humidity in between the 60 to 75% is the more influential for the high PM 2.5 concentration. And usually it happens in the twice in a day in the time of November month or winter month, because it varies from the 30% to around 100%. So in meantime, at that time the pollution level, it's contribute very high in the PM 2.5 concentration level. And the relative humidity and wind direction is also a major role in our state, that you say if there is a westerly wind, then the pollution level is high. And if easterly is set, somehow it sets, the pollution is lower down. And it's reduced significantly in the state of Bihar. So I think for the weather point of view, what we say for the prediction, if the easterly wind is going to set, the pollution level may get down, as well as if first rainfall is come in the state of Bihar or Patna, then the pollution level will also get significantly reduced. So these are the most influential factors that contribute to the or that influence to the PM 2.5 in the state, as well as other SO2 ozone is also one of the factors, but it's a least contributing. But these are the important meteorological factors that contributed highest. And for the correlation analysis I did for that one, it's also positively correlated with the carbon monoxide oxide, that is a 0.48. So if PM 2.5 is high, then there is a chances of carbon monoxide CO is also very high. And PM 2.5 is negatively correlated with the ozone in the state. So if PM 2.5 high, then ozone may be the lower down, but it's the very least. As well as the wind speed is also negatively correlated. If wind speed is less, then the pollution level is also good, get high, or PM 2.5 concentration is high. And you can see I try to make it the several analysis that how model is work. So actual as well as the predicted graph I show you. Next, please. So these are the correlation map that is come in the each and every parameter, how it correlated positively or negatively, that I also presented for during all those study period. Next, please. One of the things that how I show you that the seasonal variation is one of the important factor, and there is a no trend during the 2016 to the 2023. And what we found is from the data, from the trend data, you can see the upper part is whole data is showing, and there is a lot of peaks. That maybe the abnormal days or some day there is a very high concentration of PM 2.5. That may be the reason. And from those data, we just bifurcate or take out the seasonal data. From the second plot, you can see the seasonal variation. It's how it works. As well as in the last picture, in the lower down, it's so the trend analysis. It's not a very significant trends, but in our analysis, says the moderate level of pollution days has increased, as well as the moderate level hours is also increased. These are one of the important little bit finding of this analysis. Next, please. So now come to the conclusion, and I show you already that it's a random forest model, one of the basic model of machine learning that I used, and it's accuracy that I show you for the layman language how it works, as well as we have a RMSE, MS, mean absolute error, and all those parameters also, and miss what we call miss. Even if the heating is started after the winter season, as the heating or the even the monsoon season is approaching, the PM 2.5 level is also got down significantly because of the diffusion and all those changes in the PBL layer and all those things, as well as the wind is also playing a role. So these are some of the conclusions that I already most of the things I covered in the even analysis as well as the predictions part also. Next, please. So policy implication, we can see the reduced emissions from vehicles and dust and industrial pollutants, biomass and municipal solid waste may be the possible cause of the policy implication. So this area are maybe the major concern. Still, it's a generalized approach only, and means potential impact. We can see the finding and policymaker in targeting air pollution sources effectively. That may be the one of the finding of this research. Next, please. So these are the research part. Now IMD has a specific sections like environmental monitoring services of IMD, and headquartered at Delhi, and we are globally sharing the data also, and we have a network of pollution measuring data also, as well as the climate change is one of the important factors, and we have these many factors like ozone measurement. These all are the part of the climate change. So we have a proper network of environmental monitoring, and we are working with the Ministry of Environment, Forest and Climate Change, and we are giving all those all those input to the Ministry of Environment, Forest and Climate Change also, as well as the globally we also present in the gas station, and we are the WMO is also we are sharing those data from the other countries also through the network of WMO, and we are representing India through GA network also, and India on the WMO for this part. And we have a network of Like precipitation chemistry, we have 11 station in India, and surface ozone we have a 10 station, and column ozone from which we are getting the all those adoption unit we have a 2 station, as well as the ozone sound we have a 3 station, as well as the solar radiation station we have a 45 station across the India, as well as the aerosol. We have a aerosol optical depth measuring at 20 station. So these are the monitoring network of IMD, as well as the SAFAR program. We already know that that is in Delhi and Delhi, Ahmedabad, Pune, as well as Mumbai. That SAFAR, that is a network of monitoring station that is with the IITM, one of the sister organization of Ministry of Earth Sciences. We have also one of the collaboration project, and that from that we are monitoring and predicting for the weather air quality for the next 3 days. Next, please. So these are the environmental services, and we have a 10 station columnar, miss ozone and all those, also rainwater analysis. We are doing for the miss several years. Still, it is continuing. Next, please. So, Miss Particulate Matter, Miss in Delhi, we have a TSP, Total Suspended Particulate Matter Monitoring also, and Black Carbon Monitoring Station of 16 station we have, and from the Patna we have we do not have a black carbon monitoring station, but in Ranchi we have a black carbon monitoring station, as well as the multi-wavelength integrating nephelometer network. And that is also we have it. From that we get the even the PBL also we got from this nephelometer also. So these are the network of monitoring stations of the IMD. Next, please. So I show you one animation in which you see the how PM 2.5 is coming from the west to east in the state of Bihar, and it's flowing like a river. So these are one of the model that is a numerical weather prediction model, that is a SILAM. We know that the system for integrated modeling of atmospheric composition, SILAM model we are doing, and it's a kind of WRF model. Is the weather research and forecasting model that we are using for the weather as well as the several things. That is the advanced form of that one. So for the each and every parameter, so it's a just so you it's all those technology we got from the Finnish meteorological department that have shared, and each and every day these models are running, and each and every day analysis as well as the forecast for the spatial forecast of whole of the India we are getting. And for that we are require these emission scenarios also, and weather is one of the factors that we are using, even initial conditions that weather initial conditions weather that we are using for the our model, that same is integrating in the SILA model also, as well as the ozone and all those data is also inputting as a initial condition in the SILA model. Next, please. So these are one of the product of the state of the Patna today product. Each and every parameters you can see. It's not the actual value that it's represent, but it's the trends that that this model is showing, that will be always right. But the actual value, actual AQI predicted of the SILA may not be the actual measuring value, but the trend for the next 2 days, 3 days may be the same. Like tomorrow it will be increasing or decreasing based on the weather, that it will provide the accurate data, accurate predictions. And these are the all those health advisory that symbol we are using in the other ministry, other department that using that same we are using in our even the forecast of the miss AQI and other pollution parameters. Next, please. So we are issuing for the 45 stations, IMD issuing the 3-day forecast as well as the as well as the observation of the AQI that we are. So one of the bulletin I show you in which you can see that 2 stations of the state is like Patna, Gaya is there. So for the Patna, I think the 18th is observation is a very poor category. And in the right side, the category of the AQI is also shown. So category wise forecast we are giving for the 3 days and it issued at the 16 hours IST. Like for the today bulletin, it will be issued at the today 4 p.m. And the next bulletin will be the tomorrow next 4 p.m. and it will be valid for the next 3 days. So for the two stations of the state of Bihar, we are issuing the AQI quality forecast. Next, please. As well as the observation data, we are also. And we have a very support solicited from the State Pollution Control Board as well. So we have a very good data sharing. So there is not an issue. And we are even this Miss Pollution bulletin is also available on the website. So it's publicly even it can be used by the State Pollution Control Board and they are all aware about and they may be using it also. So these are we have a strong cordial relation and so we are hoping for the good and we will work together for the Miss. You can see the early warning system for the air quality. Maybe it will be get better and better as the technology improved, as well as the even we have a partnership will work together. So it will be improved. So these are the all those I show you the product that will be operationally available each and every day. Next, please. So for all those for as I am from the India Meteorological Department, so we have a lot of things that you can use publicly, like our website is there, even Patna website is also there, and there is a lot of app like location specific forecast. If you are planning for the Prayagraj Mahakumbh, you go for the forecast from the Mausam app, you will get the much accurate forecast as compared to the other means lot of application is available in the mobile. So you will get the more reliable forecast from this one, as well as the Miss Lightning, as well as the farmers we have also have, and we are also available on the social media like WhatsApp channel as well as the Twitter handle, and we have a 137K followers on Twitter also, and we will improve our services and it will also get improved. Next, please. Thank you for your kind attention. Please, you can ask any questions. I skip the technical parts in a little bit more early that is may not be your use, but the operational part is very important. So it's over to you. Any questions, please, and we'll be happy to answer.
Thank you very much, sir. Anand sir. One curiosity is with us. You have explained that the level of PM2O is largely influenced by the definitely, of course, meteorological parameters. In addition, with that the sulfur dioxide, nitrogen oxide, ozone gases are also responsible for the influencing the concentration of PM2.5 and the quality of the air quality. As we understand that the sulfur dioxide and nitrogen dioxide are converted to the form of salts, like sulfate and nitrates, that is responsible for the one of the components of the PM2.5. But how the ozone is going to influence that PM2.5?
I saw you in one line. Actually, your point is very right. Ozone is negatively correlated with very big negatively correlated with PM2.5. It's maybe some other maybe regions.
It is due to form. It is secondary pollutant. Without sunlight, it cannot form. Because the particulates, it does not allow the sunlight to penetrate the gases and it is not able to form the secondary thing.
Okay.
That was discussed, we have discussed in there also. No? So PM 2.5 is a boon for us because other countries are suffering from ozone. We are not.
Yeah. Okay, thanks. You give the right answer as compared to me.
In fact, we have discussed it.
We have discussed it.
Yeah.
They are suffering ozone. Nobody is highlighting. We are suffering from particulate. Everybody. That is advantageous for our health.
Yeah.
But still we will not highlight.
Okay. Okay.
Thank you.
Anyway, the thing is,
what is the chemistry behind that? How it is influenced?
It's just Miss. You can explain it. You can explain it.
actually, the ozone first.
Please on your mind.
Sir is a chemistry man. He is a very well much aware. the secondary pollutant, how it is formed.
Sulfur dioxide, nitrogen dioxide, that is being the responsible for
Yes, for
producing the
secondary
pollutants.
Secondary
But
pollutant.
ozone is how it is not forming
is-
the secondary pollutants.
Ozone is not allowed to form by the particulate because the particulate traps the sunlight.
Ozone is not formed by the particulate. But here is the issue that
What
the
is
PM2.5 is influenced by ozone.
Negative.
Not influence. No, it prevents formation.
Negative correlation.
Negative
Negative
correlation.
correlation.
Prevents.
ओजोन तभी फॉर्म होगा जब
तो अपना
सनलाइट
ओजोन को
आएगी
बढ़ा दें हमारे
सनलाइट
Inversely proportional.
Yeah.
It's a big inversely negative correlation is there.
Anyway, congratulations for your.
Nitrogen directly proportional.
और
नहीं, मैं congratulations दे रहा हूँ because 150th year.
Yeah.
You have told, no? So
Yeah.
because IMD was established in 1875.
Yes, yes.
And that is a great year. मतलब इंडिया के सर्विस के लिए आपका तुलना नहीं. And those days they have realized the value of meteorology. That is important. That's I wanted to congratulate. It's not the open. Glory is still open. Such a beautiful subject.
Yeah.
150 years of
Yes.
IMD
Yes.
and 50 years of state pollution control.
Yes.
So it is a matter of celebration for both of us.
Come and say.
That is not a matter.
Celebration
That
में
is
we
a
are
matter
joined
that we are
together.
celebrating. Good, we are improving ourselves.
So any questions?
Online participants. Kriparam Saab.
Participants,
Any participant from thermal power plants who are joining this workshop?
The Kriparam Saab is there.
ठीक है, बस हम हैं तो
अश्विनी कुमार जी पूछ देखिए ऐसा क्यों कलर की वजह से
इधर की कर रहा है
सर वो लग रहा है कि प्रोजेक्टर का
प्रोजेक्टर गड़बड़ हो गया
उसका लैंप का वो
स्टार्टिंग में शायद ठीक था अभी
बल्ब उसका सर कमजोर हो गया.
Floor is open for the online participants, please.
Manish Pandey.
But really the presentation was very informative and significant in today's.
Are you not audible, please? Online participants?
उसका नहीं है.
So if no questions are there, let us give a big hand to
I
Dr.
have
Shankar.
some questions.
नवीन जी
हाँ.
It's not a question. Not really a question.
नहीं यार
Thank
नहीं
you
नहीं
very much for.
क्वेश्चन नहीं है
नहीं,
जस्ट
बेसिक
एक
आपने बताया.
इन्फॉर्मेशन है.
We are question नहीं. मैंने पहले बोला. पहले बोला था.
बाद में चलेगा.
पहले पूछा था आपका जो आपने थैंक यू दिया. We are having a good relation with data sharing. That is a really appreciated. आजकल तो appreciate ही नहीं करते कोई भी. Acknowledge कर रहे हैं with your open presentation. That is a great thing for all of us. Right.
We are trying to, together with him and their peers also, the central office and
Subramaniam Chandrasekhar साहब होते हैं तो I would have been very much happy. कब हम लोग वो लॉन्च कर रहे हैं?
तो प्रेडिक्शन और फोरकास्टिंग के लिए हम लोग काफी.
नहीं, अरुण जी.
प्लीज.
हाँ सर क्वेश्चन नहीं है जस्ट एक इन्फॉर्मेशन है. अभी आपने कहा कि हम लोग के यहाँ ब्लैक कार्बन का कोई डाटा नहीं है तो जस्ट इट इज टू इन्फॉर्म यू दैट हम लोग के यहाँ 5 स्टेशन पर ब्लैक कार्बन लगे हुए हैं. 6 स्टेशन.
But of course not in Patna.
पटना में नहीं. पटना में नहीं.
बट मेक श्योर मतलब हमारा सजेशन यही है कि उसका क्वालिटी मेंटेन होना चाहिए. क्वालिटी मेंटेन होना चाहिए एज वेल एज वो उसका प्रॉपर कैलिब्रेशन होना चाहिए तभी वो डेटा हमारे काम आएगा.
ये हमारे सर ऑनलाइन कंटिन्यूअस मीटर क्वालिटी मॉनिटरिंग स्टेशंस पर ही लगे हुए हैं और कैलिब्रेशन इंश्योर माने एश्योर रहता है. उसका रेगुलर कैलिब्रेशन होता है मंथ में जैसा जो शेड्यूल बना हुआ है कंपनी का उस हिसाब से.
बस वही हमारा एक रहती है क्योंकि समहाउ कुछ डेटा में बहुत सारे मिसिंग डेटा वगैरह भी रहते हैं तो प्लीज इंश्योर योर कैलिब्रेशन.
जैसे आपने देख रहा था SO2 का आपने दिखा रहा था उसमें 1568 की वैल्यूज दिखा रहे हैं आप उसमें 1568 वो अभी के समय में उतना माइक्रोग्राम पर क्यूबिक मीटर पॉसिबल नहीं है. That may be due to एट द टाइम ऑफ कैलिब्रेशन,
Exactly.
वो डाटा एट द टाइम ऑफ कैलिब्रेशन का हो सकता है, उसमें फ्लक्चुएशंस होते हैं, ठीक है। तो ये सब डाटा को हटा दें।
What issue होती है range check consistency. Actually, before going for the data analysis, what we are doing the range check as well as the consistency check, as well as a lot of checks are available that we are performing, and we are just remove the erroneous data, and maybe one or two erroneous data may be presented.
ऐसा है कि जो भी डाटा आ रहा है सर, वो ऑनलाइन में एट द सिमिलर माने सेम टाइम रियल टाइम में वो सीपीसीबी को भी जाता है, हम लोग के यहाँ भी आता है। तो हम लोग जो कंपनी है उसमें उनके द्वारा कोई चेक नहीं लगाया जाता है। ये जब हम लोग डाटा एनालिसिस करते हैं उस समय उस चीज को हम लोग हटाते हैं।
Actually,
अगर हमने उनको दे दिया परमिशन कि नहीं आप चेक लगाओ, तो कुछ भी लगा देंगे,
okay, okay.
ठीक है, वो परमिशन नहीं है। ये जब हम लोग डाटा एनालिसिस करते हैं उस समय ये चेक आप लगा सकते हैं उस डाटा पर जो है।
थैंक यू डॉक्टर आनंद शंकर जी। तो एक बार फिर से जोरदार तालियों से इनका अभिवादन। और मैं रिक्वेस्ट करना चाहूंगा अध्यक्ष महोदय से कि सर अपने विचारों से और आगे के शेयर करें प्लीज।
Thank you, Dr. Anand Shankar, for this valuable talks on this subject, which is very topical for the moment. In fact, after a long gap, we are observing such a good lecture, which is very scientific, and because earlier we have a number of lectures from World Bank, WRI, UNDP, and so on. And I asked how you have built the model, how the model works, what is the predictability of the model, what is the error of this model. Nobody was able to tell me. I am very happy that you have done in a very correct manner, and it's statistically correct. The second thing is about the topic. We all know that weather component is very important, and through your SHAP model, you have proved that when the importance of weather, how much weather is important for 2.5, because it is a common in most of the newspaper and in other people. In view of common persons, everybody blames that 2.5 is increasing because somebody is not doing their work. Like in Delhi, everybody is blaming the pollution control board. Here, there is slightly blame is there. But the importance of weather we cannot deny, and we should emphasize the importance of weather in predictability of this model. The third thing is about the building the forecasting scenario for this AQI. In fact, we are discussing with the Saha that whether the AQI is the best way to define pollution. Because everybody in India, mostly people are obsessed with the numbers. Everybody has adopted some number of AQI without understanding things. So whether this is a AQI is the best thing to say the pollution level. Because if we compare the Delhi pollution or Bihar pollution, that here we don't have pollution due to gases, even NOx. So it's very, in Delhi there is a slightly higher quantity of NO2 and other gases. So without, but AQI doesn't tell. 400 means 400, whether it is from PM 2.5 or whether it is from NO2.
Right.
So that should be accounted for. And because if we are producing data for general consumption of the people, then we should be able to understand that whether they are able to comprehend the numbers or they will not able to comprehend it. Because in most of the newspapers, they are not able to comprehend the data. And they just compare 400 in Delhi means 400 in Bihar, Patna also. But the pollution level and pollution component are totally different. Okay, thank you again, Dr. Anand Shankar, for these valuable talks. And now I declare for the next lecture series, that is on 26th of December, 3 p.m. about indoor air environment, and it is by Professor Mukesh Khare of Professor Emeritus, IIT Delhi. Thank you very much.
Thank you, sir. And may I request you, sir, very humbly to present a memento on behalf of the board to Dr. Shankar.
अभी जाइए अभी जाना चाहते हैं एमडी से ग्रुप आए ना अब जाइए आगे जाइए फोटो पे कैसे आएंगे बीच में चेयर आ जाएगा
आनंद जी आने चाहिए बस
आनंद होना चाहिए ब्यूटीफुल थैंक यू मैं एक चीज में बड़ा इच्छा था फोटो वोटो हो जाए आपने एक चीज बता दिया बहुत अच्छा we are predominated by PM10 not by PM2.5